welcome to Ecoholics. Today we are going to understand a very interesting conversion related concept which is related to the Information and Communication Technology or ICT module of the UGC NET paper 1. Other than UGC NET paper 1, this is also a very common general awareness related concept as well. So this conversion is related to the binary as well as decimal system or decimal and binary numbers. So today what we are going to understand with examples is how to convert the binary numbers into decimal and decimal numbers into binary format. So let's begin with the conversion. The very first thing is, when you convert binary to decimal, what are the fundamentals that you need to learn? So let's understand the basic fundamentals when you convert the binary numbers into decimals. Now, what is binary and decimal? Whenever you have a base of 2, that is known as binary. So, binary numbers which are understandable to a computer system are always related to binary format, which means they only exist in 0 and 1. However, when we talk about decimal numbers, so that has base 10. Okay, decimal, deci stands for 10. So now what you do is you multiply each digit of the given number with 2 raised to the power 0, 1, 2 and then start right to left. Now these are just features or the rules. But how do you do this? So let's understand the application now. The very important thing that you need to read over here is start right to left. That is very important. How we'll apply this? Let's begin with understanding it. So let's take some binary number. Okay. Let's take the binary number as 11010001. Okay, run some random binary number. Okay, now you have to convert it into decimal format. Whenever you write binary number, you write it also like this. Okay, you write it like this because you want to represent it as a binary format. Okay, if this is not there, still it will be considered as binary. So these are some simple things that you can note. Now, how do you convert? So in the previous format, we had been given that we have to multiply each digit of that number that we just wrote, given number with the 2. So each digit has to be multiplied by 2. But how? With 2 raised to the power 0, 1, 2 like this. So now the easiest way to do this is, firstly we are going to write it like this. 1, 1, 0, 1, 0, 0, 1. Okay, I have rewritten this. Why I have rewritten this? So that there is some clarity. Okay, or just 1, 1, 0, 1, 0, 0, 1. That's what our number is. We have to start from right and we will have to multiply each of this digit with 2. So 2 multiplied by 1, but 2 will be raised to the power of 0. So we will start raising the power from 0 onwards. So we will raise the power of 2 from 0 to 1 to 2 to 3 and likewise till the binary digits exist. Okay, and we'll keep on adding up also. So this is the first thing. Then now 2 multiplied by 0 and 2 will be raised to the power 1 because we have already raised to the power of 0 already in the previous one. So this is 1. Now again plus 2 into 0 raised to the power 2. So 2. Then again plus 2 into 1 raised to the power 3. Then we have plus again 2 into 0 raised to the power 4. Okay. Then we have 2 more remaining. I'll just come here and write. So plus 2 into 1, but 2 will be raised to the power 5. And then again we have one more, okay, the last one, which is 2 into 1 raised to the power 6, okay. Now what happens over here? Let's understand this whole application. What's happening is we are multiplying each of this digit with 2 and we are keeping on adding these totals, okay. We are keeping on adding these totals. This is your first step. We always start from the right to left, rightwards digit to the leftward digit. So this is something that is your first step of application. Now comes the calculation. So let's first erase all of this and again now start converting, okay. So our number was 1101001. This was our original number. Now you all know that anything multiplied by 0 is ultimately going to give you a result of 0 only. So what shortcut can you now do is, while you have to multiply each of these digits by 2, but 2 also has a power associated with it. So 2 raised to the power 0, then 2 raised to the power 2 raised to the power 1, 2 raised to the power 2. However, we also know that this will again give us the multiplication will be resulting into 0, summing up to 0. Even this one. So here also what we can do is 2, now we have to see 2 raised to the power 3 and 2 raised to the power 4. So these ones will be cut out of our selection, and only for our convenience, I'll mark all the things that are going to be selected are going to be marked in yellow right now. Okay, then we have 2 raised to the power 5 and 2 raised to the power 6. So technically we have to add up all of these and then make up our decimal number. 2 raised to the power 0 or anything raised to the power is 1. So basically when 2 raised to the power 0, you will write this as 1, okay. So 1 multiplied by 1 will be giving you 1, okay, and then simultaneously you will multiply all of these. So 2 cube, okay, will give you 2 into 2 into 2, okay, 2 2s are 4, 4 2s are 8. Similarly, 2 raised to the power 5 will be giving you 2 into 2 into 2 to 2 into 2. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. And this is 2 raised to the power 6, okay. So which means there's one more 2 addition to this. So it will be 32 into 2, which will be 64. So 64 plus 32 plus 8 and plus 1 will be giving you the final decimal for the binary number 11010001. This is how we associate with our number system, and this is how we do the conversions. So this is what is the final number will be giving you the final digit, decimal digit for the binary number 11010001. So it will be 64 plus 32 plus 8 plus 1, okay. So that will be giving you what? 8, 9, 10, 11, 12, 13, 14, 15 and 3, 4 and 10. So 105 should be your decimal digit for the binary number 11010001. Now these are different questions that you can simultaneously practice. You do not need a book, you do not need any notes or any particular question series. It's just that you randomly can think about any number and just find out its any number, binary number, and just find out its decimal value. So it's as simple as this. The second type of conversion over here, the second type of conversion is the reverse conversion. So the reverse conversion happens when we talk about decimal to binary. When we talk from decimal to binary number, these are the simple rules that you need to follow. Firstly, you need to take the LCM, okay? Now, let's understand it with the, again, formula, okay, or with the example. 5, I'll write it in another color, so it's more visible. Let's take the example of 522. This is a decimal number, okay. Now, let's convert this decimal number into binary number. How you're going to convert it? You are going to take an LCM, and simultaneously you have to also find out the remainder. If the LCM is not fully, you cannot find the full solution of this particular number, then there will be a remainder, and that remainder has to be written over here outside this line, okay. Now, from what are you going to find out LCM? Only with 2, because 2 is the binary base. So 2, 2s are 4, 2 6s are 12, and 2 1s are 2. So here you have nothing. So what you're going to write? If the number gets perfectly divided by 2, then what you write is, you write the remainder as 0. So you're going to write it over here. So you write it over here. Then again, 2 1s are 2, 2 3s are 6, and you cannot divide this 1. So you will just write over here 0, okay, and here you will write 1 because you could not divide it. Then again, because the remainder is 1. So here you can also write this is the remainder. Then 2 6s are 12, 2 5s are 10. 0, 2 3s are 6, 2 2s are 4, 2 2s are 4, but still here you have 1, so you 1 remaining which cannot be fully divided, so you'll write this 1 over here, okay. Then 2 1s are 2, 2 6s are 12, so 0, 2 8s are 16, again 0, 2 4s are 8, again 0, 2 2s are 4, again 0, 2 1s are 2, again 0, and here you have the last 1 number. Now what you start calculating is, how you start calculating from bottom to upwards. So you will calculate this 1 also. So what you will do is, you will write, I should write it over here so that it will not create any confusion. So I'll write 1, which is this one, then 0 0 0 0 0, 5 times 0, then 1 0 1 0, and that's it, 1 0 1 0. So for the decimal number 522, you have the binary number as 1 5 times 0 1 0 1 0. Okay, again this is something that we have been doing since school, which is LCM, and which is why you should be thorough about it. It's just that there are some small fundamentals like calculating from bottom to up, or while the other conversion goes, you have to calculate from right to left side. So these are the small things that you have to remember. Otherwise, this is very easy. So with this, we end with the system of conversions. These are the two very, very important conversions that you need to remember and that you need to focus upon while especially going for any competitive examination which has computer system or some module related to computers or some module related to information and communication technology, which will definitely help you out in your simple questions related to these conversions. So for similar such videos, stay tuned to our channel Ecoholics. Thank you.